All right, so evaluating trig functions part 2 literally means we're going to do steps 1 through 4, which is exactly what we did yesterday, and then we add a 5th step to it. So I'm going to do a brief overview of what yesterday's stuff was. So the first thing was to sketch an angle in standard position, which just means vertex on the origin, initial ray on the x-axis, and then terminal ray wherever the heck it stops. Next thing, draw a triangle. Specifically, the right triangle to the x-axis. Figure out what your reference angle is. And that's that acute angle between the terminal side and the x-axis itself. Label the sides of the triangle using the special right triangle ratios. And so the two triangles that you need to know, 45, 45, 90. And now, like we said the other day, technically you could say x, x, x radical 2. I'm going to strip the x's out of there and just call it 1, 1, and then 1 radical 2. And you'll see today why we don't need the x's in there. The other triangle is a 30, 60, 90. Please make sure, if I make that 30, the side across from that is the 1. If this is 60, across from that goes the radical 3. 90, across from that is the 2. Right? So what step 5 is, here's our new step. Woohoo, right there. We're going to use SOHCAHTOA, so sine, cosine, or tangent to evaluate the trig function. All right. First one, we're going to do sine of 135 degrees. Now, I know you can pick up your calculator. You can double check that it's in degree mode and you can calculate it. If I show this, I'm going to zoom in here. I'm going to check my mode. It's in degrees. And if I type in sine of 135, it will give me an answer. It's just going to give me a decimal answer, which is fine. But if the question says evaluate it exactly, which is what we're going for here, I don't want this decimal that runs on forever. This is an approximation because eventually the calculator does round it. So how we do this, let's run through what we did yesterday. I'm going to zoom out just a smidge here. Start by drawing the angle. So draw a set of axes, 135 degrees. That's an obtuse angle. So it's going to land, or the terminal side will land over in quadrant 2. I'm just going to shimmy this back a little, give me some space. There we go. So it's going to start here and rotate over to here. That's my 135 degree angle. All right. My reference angle is always the angle between the terminal side and the x-axis itself. Right? So when I draw that triangle, I want it to be that little acute angle inside the triangle. So I have to think about it as going all the way to 180 and then backtracking to get that reference angle. So I want you to think of it as 180 minus 135, or 45 degrees right there. All right. Since it's 45, that means I'm using this guy right here, the 1, 1 radical 2. So 1, 1 radical 2. Don't forget, part of the labeling is you had to think about what direction things are moving. So if I'm going left, that's negative. If I go up, that stays positive. Hypotenuse, always positive. All right, that finished what we did yesterday. Now what we're going to do is take the sine of it. So to do sine of 135, what we want to look at is that's equivalent to taking the sine of the reference angle. Just, we're in quadrant 2 now. Right? So it just matters that the triangle's been drawn over here. So when I think sine, we're talking opposite over hypotenuse. So the opposite side, that's this guy. Adjacent's here, hypotenuse is here. So opposite over hypotenuse, my answer would then be 1 over radical 2. And then we quickly did this yesterday, or maybe it was the day before, where you have to rationalize it. So you multiply by whatever radical's in the denominator, which in this case will give me radical 2 over radical 4, which is really just radical 2 over 2. That is my nice exact answer for the sine of 135 degrees. So let me go back to my calculator here. We said it's approximately 0.707 or whatever. So now if I type in radical 2 and divide that by 2, there you go. That is the exact answer. These are the approximates. Right? So can you check your answer every time? Yes, you can. Remember that. All right, example 2. We're going to use the exact same diagram to keep this simple for us. So use the same picture. We're going to do cosine of 135 degrees. So I'm going to try to open this view so that you guys can still see. Just got to get my computer out of the way. There we go. So you can still see the diagram to be able to use it. So cosine of 135, I would draw the picture. I'd label the sides. I'd do all this stuff. Yay, it's done. All right. What that means is it's equivalent to cosine of 45 degrees, but when it's drawn in quadrant 2. Why that's important. All right, cosine A over H. Well, in the picture, the adjacent side, it's not just a 1, it's a -1 because of it being over in quadrant 2. So it's -1 and then over that radical 2, which you would rationalize just like you did in the last one. So my answer is going to come out pretty similar, but it's going to be negative radical 2 over 2. All right, calculator check. Bring your calculator back over. If you type in cosine of 135, there you go. There's that same answer, but negative. And so what we'll eventually talk about is when we look at the graphs, why is it coming out positive, negative, and so on. But it's based on where the triangle is located, what quadrant it's in. And we'll talk about those patterns, but that's not a topic for now. That's a topic for next week. All right, let's do one more example, and let's make it with radians. So example 3, let's do the tangent of 11 pi over 6, right? We start by drawing it. So give yourself a set of axes so that you can draw this thing. Remind yourself, in radian measure, 180 is the same as pi. So this top half, this straight angle, has to be broken up into 6 parts. So when you draw this in, you're breaking it up into 6 pieces. So 1, 2, 3, 4, 5, 6. Now I need 11 of those pieces. So you know the drill. Keep going. Extend those lines. So here's 7, 8, 9, 10, 11, 12. So the angle 11 pi over 6 starts here and it goes all the way over to here. All right. We said the nice thing about radians is that pi over 6, that is the reference angle because there's one of those little slices right there. And pi over 6, if you need to, remind yourself that's the same as 30 degrees. So sometimes it helps to kind of translate it back into degrees to understand it a little bit better. All right. So if that angle right there is pi over 6 or 30 degrees, the side opposite is the 1. The side adjacent is the radical 3. Hypotenuse is the 2. Think about the direction. From the origin, you go right radical 3. That's positive. You go down -1. There we go. And the hypotenuse always stays positive. All right. Tangent of 11 pi over 6 is the same as tangent of just pi over 6, but it's down here in quadrant 4. Now, you don't really have to show this on your work every time, but I want you to think about the fact that it'll be the same, but it's slightly different because of where it's located, right? Opposite over adjacent. Pick them right off your picture. So the opposite, -1. The adjacent, radical 3. And oh, I picked another messy one. So you have to rationalize it. So radical 3 over radical 3. And then I get negative radical 3. That would turn into the square root of 9 or just plain old 3. All right. To check this one, you need to be in radian mode if you want to type it in the way that it is. So I'm going to, went to grab my calculator. I picked up my cell phone. That's not helpful. I'm going to change it so that you can see it. So go to mode, change it back to radians. And then I'm going to zoom in a smidge so you can see this a little closer. I'm going to type in tangent of 11 pi over 6. And it's going to give me this negative 0.577. All I'm checking is this expression the same thing? So negative radical 3, and then divide that value by 3. There you go. Same thing, and it checks out.